is, you know.
Hey everyone, my name is Lori and I am the head of community here at Percona. And we have a very special guest with us today. We have got Dmitry, if you want to go ahead and introduce yourself.
Hi, my name is Dmitry Polyakovsky. I'll be doing a presentation about how we can build some interesting extensions to Valkey using a Rust programming language. And in my day job, I'm actually work at Oracle Cloud, and I'm a lead engineer for OCI Cache service, which allows your customers to have managed Redis and Valkey servers. But as I said, here I'm speaking as a maintainer of the maintaining the Valkey Modules Rust SDK.
Awesome. And so before we begin, I have a little housekeeping. So we are happy to take questions. If you're watching via YouTube, go ahead and put YouTube questions in the chat. If you're on LinkedIn, same thing. We will catch them all here and we will take the questions at the end. So Dmitry, before we begin, I think we need to set ourselves up with a little bit of history about Valkey, about Rust modules, and about how this all came about. So why don't we start at the beginning? Tell us a little bit about how Valkey became Valkey.
Okay, well, let's start a little bit farther. Let's start with Redis. As I said earlier, we're going to do some time traveling. Okay, so Redis originally emerged about 15 years ago when its engineer Salvatore Sanfilippo needed a fast in-memory database. And he open sourced this project. It became very popular. And then a company came along, which eventually became Redis Labs. And they adopted the project and they started trying to make it commercially viable. And then in 2018, Salvatore created something called modules, which were basically extensions or plugins for Redis at the time. And the reason for that is because a lot of people were coming to him and saying, what if Redis could do this or that? And it didn't make sense for the core Redis functionality, but it made sense to enable people to extend this themselves without having to fork the code. So modules happened in 2018. Now that's fast forward a little bit, let's say 2 years. So in, no, wait, not 2 years. Oh, yeah. So in 2 years, basically in 2020, what Redis, the company, did is they introduced the ability to build these modules in Rust, and they created an SDK for that called Redis Modules Rust SDK. And the reason they did that is because modules had to be built in C or C++ until then, and lots of engineers weren't as familiar with that tool set. So by supporting Rust, it kind of expanded their Redis module ecosystem. Okay, now let's jump a few years ahead. And in 2004, what happened is that Redis changed their license. And it's a very long and complicated story, and we don't have time or the lawyers on this stream to discuss all the nuances. But let's just say that as a result of that change, which happened about a little over a year ago, a project emerged called Valkey. And Valkey is a play on key val. And if you're really interested, you can go on GitHub and find the original issue where people were brainstorming all kinds of names. So the Valkey project emerged as a true open source project under the umbrella of Linux Foundation. It has participants from multiple software vendors. Myself, I work at Oracle Cloud, but we have folks from Amazon, Percona, Google Cloud, and many others who are contributing to it. And there's a technical steering committee, but all the intellectual property is held by the Linux Foundation, which makes it a true open source project. So that's kind of the story of that. Now, when the Redis Valkey fork happened, what we also did is we forked the Redis module Rust SDK, which became the Valkey module Rust SDK. And I've been maintaining that for the last year plus. And other engineers have also made contributions to that.
Okay, so everybody, I hope we're all caught up to speed. We're back in 2025. We are here with Dmitry, and he's going to walk us through the Rust module he built for Valkey. So Valkey, again, is a truly open source project backed by the Linux Foundation. Percona is a part of it. Oracle's a part of it. AWS, Google. It's an amazing project. And if you want to learn more, as Dmitry said, you can go to the GitHub. You can go to the website. But enough chit chat. Let's get into business. Let's do this.
Okay. All right. Well, let's actually ask the first question. Again, why should we build modules? Why can't you just write client code or maybe build a library or maybe do a Lua script? And the answer is that using a module, you can do things that are simply not possible otherwise. You can create a new data structure. So one of the first modules that emerged, I think about 6 or 7 years ago, was Redis Search, which enabled full text search inside Redis. So you get the speed and ability to search for data using something other than its key. And then other modules emerged. There was support for JSON. There was support for, a time series, graph, etc. Well, Now that we've answered that question, let's ask the second one. Why should we build the modules in Rust? What's wrong with C++ or C? And the answer is nothing. If you're comfortable, if that's your tool set, go build modules in C. But I'm personally excited about Rust, so I will talk about building modules in Rust. And now enough talking, let's start the demo. Let me share my screen, and then we will start writing code. Okay. All right, can you see my screen?
Yep, we are good to go.
All right, so I have here my bash command prompt, and I'm going to type a command called cargo new rust mod -- lib. And let me explain to you what this does. So cargo is a package manager for Rust. And what it allows you to do is allows you to do things like compilation, unit testing, and also manage dependencies and create new projects. So here I'm opening this project in VS Code. And you can see that in addition, the Rust mod is the name of this project, or crate, or library. I'm going to use those terms interchangeably. And -- lib means it's a library. And the reason it's a library is because you can have binary executables in Rust, or you can have libraries. And we're building a library because at its core, Redis modules are just DLLs. So let's commit this code and start making some changes. So first, I'm going to customize my gitignore file a little bit to make sure I don't have my RDB file saved when I'm running Redis or Valkey. And second, I'm going to start adding the libraries to my cargo toml. So toml is the dependency management file, and I will do it like this. I'm going to add a new crate here by running this. And now I'm going to compile it. Oops, cargo B. And another change I have to make here, and this is a Rust specific thing, is that I have to specify the type of a crate called dynamic library. So all I have to do is paste this. So don't worry about the nuances, but what it's going to do right now, what's happening behind the scenes is it's compiling this SDK and all of its dependencies, which you can actually see in this log file if you're really interested. And it's going to produce a .dylib file. And we will be able to see it in the target output folder. So you can see here that there's a target folder, there's debug, and then we will see shortly a library that we'll be using. And we will also create a new file called valkey.conf, which we'll use to start our Valkey process. We don't have to create it actually, but it's just a little bit simpler. So in this valkey.conf file, we will specify a command to Valkey to load module and give it the path where this file is going to live. So it's going to be here any second. All right. So now that we've built this code, oops, let me actually amend. Cool. So let's look at actually the Rust code. And you can see here that this doesn't look like real functionality. It's just some demo code that was auto-generated for us when we did the cargo new command. So let's copy and paste a little bit of code from I'll show you later in the Valkey Modules Rust SDK, there's a bunch of examples. And this is one of the examples that I customized a little bit. And let's again add this code. Okay, so let's recompile it. All right, so I think we've got all that working. Let's now walk through code gradually. So you can see here that I'm using certain features that are coming from this Valkey module Rust SDK. One of the things that's really important is the Valkey module exclamation, and that is what's called a macro in Rust. So if you're interested, check out macros, but to make the long explanation short, macros are basically metaprogramming that allow you to write code that writes other code, and it really simplifies that development and just like auto-generates a bunch of stuff for us. Again, if you're interested, double-click on the Rust SDK, you will see all the details of these macros. But for now, let's just focus on what this does. So what we're doing here is we're creating a new command, rm.mul, and we're giving this module a name, Rust mod. So now if I run my Valkey server process and give it the valkey.conf file, which we created locally earlier. By the way, you can see here this lib rustmod.dylib, which is the file that is actually the module. And it's a very small file, maybe a few megs at most. But this Valkey process is now started. and using this configuration, it's loaded the module. And we can actually see it in the output right here, module Rust mod loaded. Okay, let's connect to our Valkey process using Valkey server, using Valkey CLI, and check if it's actually loaded this module. Module list, yep, it's there. So now let's try to execute this command, rm.mul, well, I put dot, rm.mul. Okay, it's going to give us an error. Let's try to understand it. So here we have this check, args.len, and it's basically checking array of vector of arguments. Now, with Redis or Valkey modules, the first argument is always the name of the command. So it's going to be rm.mul. But the second argument, which we're missing here, is what we need to specify. So if we specify 1, we can see it responds with 1, 1. Well, that's interesting. So what does this code actually do? Let's actually specify something else. 1, 2, 3, 4. Okay, so it returned us the original arguments, but then it returned 24. And we can do some simple math and realize that 24 is 1 times 2 times 3 times 4. Okay, so we know that this command does, but let's look at the code to understand it a little bit deeper. So what we're doing here is we're grabbing the arguments, we're turning them into something called iterator. We're skipping the first argument, which is, as I said earlier, the name of the commands. Then we are parsing each argument to make sure it's an integer, because if I say this, it's going to give us an error. And then we're collecting it back to a vector, which is, think of it as like an array, but now it's a vector of integers. Okay, and then we are iterating through this array or vector and simply multiplying all numbers and taking the response, adding it back to the array and responding back to the client. So like I said, you give it 1, 2, 3, 4, it returns you 1, 2, 3, 4, and then also gives you the result of multiplying 1, 2, 3, 4. Okay, that's kind of interesting. Not very useful, however, but it's interesting. It shows what we can do. And like I said before, in addition to commands, you can create the custom configurations, you can create additional data structures. So as I said, the JSON and full text search or vector similarity search are extremely popular, and those do require both commands and data structures. And again, those would not be possible to do without these without ability to write code that runs inside the Redis or Valkey process. I mean, you could probably get by with just serializing data to strings and saving it in Valkey as a string, but in reality, it's a complex JSON, but that is not very performant. And also, you won't be able to like search inside that. So again, lots of things are possible without doing modules, but certain things are only possible with modules. Now, the one caveat with modules is, as you can see here, that I have to have direct access to the server when running a module. And that is simply not an option of using a managed cloud service. On the other hand, if you're running your own infrastructure, whether it's on-prem or in the cloud, just on VMs, you can SSH to them, you can run Valkey process, and then you can get your own modules written in Rust, but also written in C, and get them inside there and run them. So those are the, like I said, some of the caveats, but also some of the advantages. All right, so let's now try to do something a little bit more interesting. Again, we have a command that just multiplies numbers together. What if we wanted to somehow integrate our Valkey process with some third parties APIs? Well, this is where ability to build these modules on Rust is super useful. So I'm going to add a few more libraries to my dependency file, cargo toml. And I will add another command to my module. So what this command will do, and again, I'm going to just copy and paste the code, but then I'll walk you guys through it. So it's going to be a command to make HTTP requests. As I said earlier, what if we wanted to somehow integrate our module, our Valkey process, with a third-party API? Okay, let's add the code, and let's walk through it in detail. So first, what did I do here? Well, I added several libraries. The first library is request. It allows you to make HTTP requests. And this is a feature that's part of the dependency management in Rust, is that you can activate some of the features within a library. So here we're installing a request library and activating the JSON feature within it. Here we're installing libraries to do serialization and deserialization in JSON. And here we're integrating a library called Tokyo to do some asynchronous requests. Again, if you're interested in those libraries, feel free to Google them. There's lots of information online. They're very popular. But now let's get to this code. So you can see here that I introduced a new command. I called it, call it rm HTTP. So what does this do? Well, it allows us to make HTTP requests. Why would we make HTTP requests? Well, we want to integrate our Redis or Valkey with some kind of an API. We have some kind of systems we're writing in our companies. Here, what I'm using is I'm using a simple HTTP bit. And all this does is allows me to just get information about my current browser or client. So not super useful, but it allows me to basically get some JSON back from an API, which is what I really care about for the purpose of this demo. So here's an important thing is that this origin, that is the IP address with which I'm making the request. And if we look at this code here, you can see that this is what I care about extracting out of the JSON. But I'm able to do all this with a fairly little code that I wrote on my own. I'm using all these libraries, and they provide some really nice features for me. First, I'm using this request library to make a GET request, and I have asynchronous capabilities to wait for the response. Then I'm able to take this result and check to see if it's successful or error. And those are, again, just provided to me by the underlying libraries. So if there's an error, I'm just going to say, hey, request failed. And that will happen if I, let's say, provide a wrong URL or if that API is down at this time. Now, if I do get a successful response, I then need to check to see if it's a valid JSON. And here I'm basically taking this JSON, I'm using this SERDI library to handle it. And then if it's able to successfully parse it, I extract the origin attribute out of the JSON and return it as an output. Otherwise, I return an error message. All right, let's try running this and see what happens. So again, I restarted my process loading the modified version of the library. And okay, I can see that it's running. And now I'm going to rm.http. So it takes a second because it's literally making an HTTP request, but you can see that I have received a response from the API. And if we look here, we can see that it's the same IP address, 73.118. So we're able to take our C code, or extend it using Rust, and integrate it with some API that is maybe we don't control, but we just need to get some information from it. And to do all this code in a client library would be simply not possible. Like if you're writing, like let's say a Java library to integrate with Valkey. Or if you had to write it in C, you would have to write a lot more code. And here we were able to just take advantage of all these pre-built libraries. Okay, so that's it for the demo. Now let's talk more about the project. Okay, so first of all, if you're interested in learning more about the Valkey Modules Rust SDK, you can check out its website. And let me share the screen here and walk you through it. So there is a GitHub page, obviously. So here, and you can see a lot of examples. So examples contain, but for example, what I showed you here. But there's also other examples to handle things like server-side events. It shows you how to create new data types. It shows you how to create custom configuration, how to actually take advantage of certain macros and so on. Lots of really good examples. We've been adding to them over the last year as we've been maintaining the Rust SDK, but check it out. If you're interested, of course, feel free to dive deeper in, not just go beyond examples and go into the actual source code of the library, of the SDK. You'll find a lot of useful stuff, but it does have a little bit of a learning curve and you have to be pretty familiar with Rust. Now, if you don't want to deep dive into Rust and you still want to build modules, again, you can build modules in C. So for that, you can go to the Valkey project itself, and you can start with a Valkey module.h. And the header file basically is what exports all of the APIs that are available in underlying Valkey modules. And the Valkey SDK also has a lot of examples. So there's like, for example, hello world that shows you just really basic commands. There's a hello type, which shows you how to build custom data types and so on. And there's also some really good tests which have examples. So feel free to check it out. Again, you will have to write code in C. But sometimes it's useful to actually start with these modules and get ideas and then jump into the Rust SDK and implement them in Rust. The Rust SDK at this point should support all of the underlying features of the Valkey itself, because about a year ago, there was actually a lot of things added in the Redis and then Valkey. but they were not yet available in the Rust SDK, so you couldn't take advantage of them. But over the last year, we've kind of closed that gap. You can also go to crates.io, check out the documentation about the Valkey Modules Rust SDK. You can see there have been quite a few changes over the last year. You can read the documentation on the docs.rs website. And you can also check out a couple of blog posts that I wrote over the last year. So this happened in, let's see, in May of 2024, as we literally shortly after we forked the project. Again, in addition to forking Valkey, in addition to forking Redis to become Valkey, we also forked the Redis module Rust SDK to become the Valkey Modules Rust SDK. And I kind of walk you through some really basic concepts here, and I show you how to build modules in C and in Rust. And then about a month ago, I wrote another blog post summarizing all the changes that happened in the Valkey Modules Rust SDK in the last year. So I talked about, for example, we added a lot of really useful features to get information about the clients available. To at least now support authentication callbacks, which is a new feature in Valkey 7.2. We added support for filters, which can be executed before commands and allow you to modify command behavior if you need to. We added support for additional server-side event handlers, additional validation for configurations, and support for defragging. And we are still able to support recent version of Redis. So if you need to build a module that's compatible with both Valkey and Redis, you can do that, and we give you examples how to do that here. Okay, I think that's about it on the demo and on the walkthrough of the documentation. Laurie, are there any questions?
We do have a question. Let me get set up.
Great.
And here we go. Okay, so right when we started, Nib asked, is there a velocity fluctuation for the coding?
I'm not sure. Could you clarify what you mean?
So I don't see him responding, but we'll see.
Okay. I'm gonna, is there velocity fluctuation? Like, is it faster to build modules in C versus Rust, I'm guessing? If you could, I'm gonna assume that was the question, but please clarify if that's not the case. So I would say that it depends on what technology you're familiar with. If you're like a hardcore C programmer that knows all the tricks, then yeah, you can probably build modules in C, and it's gonna take you a little time to get familiar with Rust. However, I would just show you how I was able to take advantage of several Rust libraries to make HTTP requests, to do serialization and deserialization, and to even handle asynchronous requests. I'm not as current in my C programming, but I suspect it would take me a lot longer to do that in C. So that's kind of I believe you talked about developer velocity. As far as the performance of the underlying source code, I haven't seen differences between Rust code and C code, but there may be. And again, I would argue that if you are using Rust and you're just saying, oh, let me just grab this library, well, you got to be careful, because that library or crate can have additional dependencies, and it can significantly increase the size of your module. And yes, there could be certain performance bottlenecks in those dependencies. So please test your code.
So we don't have any other questions, but before we go, I did want to give another shout out to the Valkey project. Now, if you want to contribute, what is the best way? Like if you're interested in Valkey, what is the best way to go about it?
Oh, just check out our project. In fact, let me show you a couple other things. And so you will see a lot of repos on the Valkey on the GitHub page. And let me share the screen again. So what you will see is, first of all, here's the Valkey repo itself. So there's lots of issues. Feel free to check them out. Feel free to submit a pull request. There's also this Valkey Modules SDK repo. So again, there's some issues there. There's some pull requests that I need to review. But there's also a couple of interesting crates or libraries that were modules that were built using this Valkey Modules Rust SDK, if you're interested in that. So there's, for example, Valkey Bloom library, which takes advantage of the SDK to build support for Bloom filters. And another recent addition is support for Valkey LDAP authentication. Again, this library leverages a lot of their Rust SDK, including the recently added features, and allows you to enable authentication for your props, for your Redis or Valkey service using LDAP service. And feel free to just start contributing to those.
And I think the other thing that is really cool is that this is a truly open source project backed by the Linux Foundation. It will always be open, and to have such a charter for community contributions, right? To start from Redis, to fork, become Valkey, and then to double down, and to welcome Valkey back to their form of open source, but to just know that the community is moving everything forward through Valkey and the innovations. If you guys look at the first iteration, Valkey, 7.1 to 8.0 to 8.1 now, it's been amazing to see how quickly everyone is kind of coming together.
Yeah, and there's Valkey 9 in the works, so will be released. Well, can't speak to the dates yet. So, but yeah, again, it's an open source project. It's guaranteed to stay open source. We are currently BSD 3 licensed, so we have no plans to change it. We have no incentive to change it. So check out the project, see how you can use Valkey itself, and see how you can potentially extend Valkey to use some kind of a custom use case, and maybe write a module.
And just a little plug, if you happen to be going to Open Source Summit North America in Denver next week, Valkey will be there. Percona will also be there. We'll have a booth, so there's plenty of people for you to talk Valkey shop with. And then when is your meetup in Seattle?
Oh, so yeah, I was going to actually just mention. So I'm also well, okay. So a couple of things. First of all, there's a Seattle Rust meetup, and I'll be actually doing a very similar presentation at the meetup this week. But I also run the Valkey Seattle meetup. So if you Google Valkey Seattle meetup and you're in the area or you're visiting Seattle, feel free to check out the meetup page. We try to have a cadence of about an event every couple of months, and we've had about 50 to 60 attendees. So there've been some interesting presentations. We were able to record, for example, the last one, and it's posted on LinkedIn. So yeah, we actually have a nice growing community in Seattle for Valkey, and it's kind of convenient because myself and some of the key players from AWS and GCP are also based in Seattle. In fact, we knew each other before the whole Valkey fork happened.
Well, Dmitry, thank you so much. And thank you to our viewers. If you want to watch this again, we'll have it on YouTube. So always available for you to watch and to kind of follow along. And so thank you guys. We're going to end the stream, but have a great day, whatever time of day it is.
All right. Bye, everybody. Thank you.